Did you see the board?
Yes.
Do you understand long division? Was easy or no?
It would be good if you give another example.
No, of course. I have 3 examples for you. But I want to solve in the same example using synthetic division. Synthetic division is like a shortcut of the long division. Entonces, synthetic division is possible using only when the polynomial in the denominator, this guy, is degree 1. It's linear, exponent 1. Degree 1. Entonces, we create a shortcut. It's called a synthetic division. It's similar. You open the symbol again. You copy here inside the box the dividend, but you copy only the coefficients 1, 3, and -54. You omit the variable x squared, x no. Entonces, the most important thing is, pay attention, please. The divisor, que es x plus 9, you copy here, but with opposite sign. Opposite. See, it's positive in the expression, you put negative in the synthetic division. Why? What's the reason? Remember, systematically, I need to change the sign by subtracting, change the sign by subtracting, change the sign by subtracting. No. In the synthetic division, you change the sign one time. It's mine. Bring down 1 directly. No operation. Bring down 1. Bring down the first number. Multiplication 1 times -9. -9. No? Combine that term here is -6. Multiplication again here, this and this, is 54. Positive 54, no? Because negative is positive. And the remainder is 0. This 0 is exactly the same this 0. Okay? And what's the answer? The answer is this guy. Look at that. But you suppose that this guy is -6 x to the 0, and this is 1 x to the 1. The conclusion is x minus 6. It's exactly the same of this answer. Okay, either way, guys. But well, the long division is more general because we can divide when the degree is not necessarily 1, but when you see that the degree is 1, nice, you can use a synthetic division. Either way. You propose me synthetic, professor, or long division. Okay? Any question? No. Yes.
I don't understand yet, but because you're gonna do another example, I'm waiting.
Better be patient. Of course. I explain, slow down, okay? Don't worry. Everything is okay. I predict everything. Wow, what the hell is that? Another problem I have here. Another class. No, it's the same class. Okay. Another example. Example 2 for you, especially for you, is x squared minus 12 plus 32 division x minus 4. What do you prefer, long division or synthetic division? Come on, it's up to you.
Can you do both?
Can you do both? Okay, bueno. Why not? Good. Very good. Okay, I copy that like that, this symbol. X squared minus 12 plus 32 x minus 4. It's obvious that the expression is x because x times x is x squared, and x times -4 is minus 4x. By subtracting, change the sign. This is cancel, always cancel. And bring down, this is -8x. Finally, bring down 32. Entonces I suppose que es -8, no? Because -8 times x is -8x, exactly the same. And negative become positive. But by subtracting, I change the sign. This is positive, and now this is negative. Again, the remainder is 0, and the answer is then x minus. Okay. Using untitled division. Is, remember, similar. I open that symbol, but I put only the coefficients because the coefficient is 1 minus 12, 32, no? And you put here the number and the divisor, this, but in opposite side. If you see negative 4 here, it's positive. Bring down 1, multiplication 1 times 4 is 4. Combine right term here is negative 8. Negative 8 times 4 is negative 32. Remain the 0 again. This 0 is exactly the same, this 0. And the answer is x minus 8. Because in my mind, I suppose that this guy is x to the 1. This is x to the 0. Okay? X to the 0, you know, is equal 1 is invisible. And exponent 1 is also invisible. And this is the answer. Super easy. Super easy. Super easy. Any question? No?
I think I'm starting to get it.
Uh-huh. Okay. Okay, very well. Scientific division. Okay, this chapter for the test number 3 is very important, super important, crucial in algebra. Let me explain why after. No. Okay, I want to raise the board. Okay, there you go. The next, number 3, is y squared plus 10y plus 25 over y plus 5. Long division, I take it. M. I forgot M. Okay. And long division is, let me try. Y squared plus 10y plus 25 divided by y plus 5. Es obvio que es y, ¿no? Because y times y is y squared, and y times 5 is 5y. Positive. By subtracting, I change the sign. Now it's mine. It's cancel, always happen, and this is 10y. 10y, no, 5y, because 10 minus 5 is 5, positive 5y. Bring down 25, and now it's obvious que es positive 5, ¿no? Because positive 5 times y is positive 5y, and 5 times 5 is 25. I subtract the change the sign, remainder 0. In this case, always the remainder is 0, but not necessarily 0. And the answer then is a coincidence. The answer is exactly the same, the dividend. So it's y plus 5. Okay? Because if you multiply, okay, let me take advantage of this idea. If you multiply y plus 5 times y plus 5 like that, like a cross multiplication, let's see what happens. We foil. Y times y squared. Y times 5, 5y. 5 times y, 5y again. And 5 times 5 is 25. And when you combine like term again, 5 plus 5 is 10. And we come back at the beginning. This is polynomial. It's exactly the same, the top polynomial. Super. Okay, let's do in long division, synthetic, sorry, synthetic, by curiosity. And the test, not necessarily you need to do it in both ways. Only one way is correct. Synthetic is 1, 10, and 25. And you divide by y plus 5, so you put -5 here, opposite sign. This is the key idea. Bring down 1, multiplication, and -5. Okay, that's 5. 5 times -5 is -25. Remain the 0 again. And the answer is x plus 5. It's exactly the same this. Super easy. Super easy. Synthetic division and long division. No problema, right? Yes or no? I am right, I am wrong. It's easy, it's complicated? No.
The last one you have
It's easy.
y
I
plus
get it now.
5 or x
Oh, wait,
plus
wait,
5.
only one student talking. Come on, come on. What do you say,
You
mister?
have you have y plus 5 or x plus 5. The
No.
second.
Ah, sorry, you are right. Our, I don't know why. You're right. Okay, the variable in this problem is y, no x. Therefore, is y. You're right. Y plus 5. The habit is x, 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 x. Always x. No, 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 no. Okay, guys. Any question? Any question? Another student say something. Okay, I don't hear very well.
No
Everything
problem.
clear? Clear, right? Okay, let's go to the most important moment now. The most important moment now is the initial of the one topic, extremely important topic, let's call it factorization. Factorization is extremely important in algebra. Okay, we spend a lot of time today and next day to explain every approach, every technique of the factorization. Okay, by the way, there are several. And the student need to memorize and need to use the application, no? Apply. And factorization is crucial in algebra because we can do several applications of this throughout the course, not necessarily today. Okay, so the factorization is crucial, but factorization have different technique. Que I separate in this. Look, the first one we study now in a few seconds is GCF. GCF. So GCF is greater common factor. So the greater common factor is very easy. Suppose I want to find the greater common factor between 5, 10, 20. So I need to find the greater common factor in between 5, 10, and 20. The systematic way we can do, okay, mentally we can predict what's the answer. What is the common factor between the greater common factor between 5, 10, and 20? What is that, in your opinion?
5.
5. It's all big 5. However, sometimes it's not too easy to see directly, and the systematic procedure is you take the number one by one. Okay, you are doing the factorization. Well, the factorization 5 is impossible factorization because 5 is prime number, right? But 10 is 2 and 5, 20 is 2 and 10, and 2 and 5. Are you familiar with this typical format of factorization? This is three format. Are you familiar or no?
Yeah.
Yeah, you're familiar. Okay. Now I can see que 5 is a common because it's the factor que this number share. Okay. Let me try another example. Suppose the common factor in between 40 and 72. Could you find or no? It's complicated, right? I cannot find. No. It's always factorization. You break it down. You break it down 40, and you break it down 72. 40 is even, no? 220. Okay, my recommendation is the factorization you are doing in this order, in the order of the prime number. And the prime numbers is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and this is infinity sequence, you know? Basically, this is the most important to memorize. So you start in 2. When this is impossible by 2, you start by 3, by 5. You following that sequence. By 2 again, it's 10. By 2 again, 5. And this is the prime factorization. So 40 in my mind is 2, 2, 2, 5. 2, 2, 2, and 5. Or 2 to the third power times 5. Okay. 72 is even. It's even. It's 2, 36, 2, 18, 2. You put in the calculator, guys, if you want. Division. Division by 2, division by 2, division by 2, division by 2. This is 9. And 9 is 3 and 3 because 9 is impossible divided by 2, so you continue by 3. Okay, so 72 is 2, 2. 2 to the second time. No, 2 to the third. Sorry. 1, 2, and 3, 2, and 3 to the second. This is a factor. Okay, now this is a crucial moment to find GCF. GCF. It's more clear now or no? GCF. How many 2?
Yeah.
How many 2 we have in common? How many 2 we have in common in between that number? How many 2? How many? How many 2 in common?
3.
3. 1, 2, 3. 1, 2, 3. How many 3 we have in common in between both numbers? How many 3?
Nothing.
No 3, because 72 have 2 3, but 40 have no 3. How many 5 we have in common?
2. No, nothing.
No 5, because 40 have 1 5, but 72 have no 5.
Yeah.
Therefore, the greatest common factor is 2 times 2 times 2, so 2 to the third power is 8. Any question? Any question? Do you understand very well the systematic way for finding always greatest common factor?
Yeah.
Uh-huh. Okay. I feel it, no? No, because sometimes we have expression that contain variable. Suppose just algebra, just variable, no coefficients, no. Suppose what is the great common factor between x7, y8? Another expression, suppose x2, y6. What is the greater common factor? Greater common factor. And between this expression, x7, y8, comma, x2, y6. Well, I have no idea. Let me try to understand. It's exactly the same. It's exactly the same. X to the 7 is 1, 2, 3, 4, 5, and 6, and 7x. And x to the second is only 2. Yes or no? Therefore, the common is obvious is that part. Entonces, at least the great common factor in the x part is x to the second. Wow, it's easy. Entonces, you take always, you have two exponents, 7 and 2, and you take the smaller exponent. Entonces, in between y8 and y6 is y6. End story. Super easy. Super easy. Everyone follow me? Okay. Yes or no?
But
Yes.
why you didn't take y8? You take only y6.
Because similar idea, look, y8 is 1, 2, 3, 4, 5, 6, 7, 8. AY. and 6 is 1, 2, 3, 4, 5, 6. And you can see that 6y is common. That is the reason I take the smaller. The shortcut, remember, a smaller exponent. Right? Right?
Yes, thank you.
Okay, my pleasure. Okay, now let's go to example 4. And example 4 say, factor out. Factor out. Factor out what? The GCF. GCF. And our expression is 40, 40x to the 7 power, y to the 8 power, plus 72, x to the 7 power, and y to the 6 power, plus 72 again. It's a repetition, the same number, okay? X to the 4 power, y to the cube power. Okay, what is the first step? The first step is step 1, important step, find the GCF. And we did before, no? The great common factor and the numerical part was 8. Do you remember that or no? You remember or no? Let me see. Yeah, it was 8. Look at that here. And between 40 and 72. Well, this is by coincidence repeated 72. So it's okay. The analysis is the same. And what about the variable? X is common. I have X here, and X here. But what exponent is the GCF? And Y is also common, no? Exponent. X to the what? And Y to the what? This is 3, no? Let me see. This is 3. 3. So the exponent is, the smaller exponent is 2. Look at that here. And 3, no? This is the GCF. Okay? Everyone follow me so far? No?
Yes.
Okay. Yes. Now, step 2, que is the last one. Yeah, that's it. You factor out the GCF. You put outside. You put outside. The great fact. Open new parenthesis. And inside the new parenthesis, you copy the remaining part. What is the remaining part? Look. In my mind. Okay, let me try here. Again. Let's do it again, the factorization, because I want to make sure. 72, 40. This is 2, 20. This is 2, 10. This is 2, 5. Okay. This is 2, 36. 2, 18. 2, 9. And this is 3. And you factor out 8. And A is this guy. 3, 2. Now this guy go outside and only stay inside the parenthesis 5. Well, 5 and the 40. So I copy 5, x to the 5th power, because we have 7, no? You factor out 2, of course, stay 5, no? And y, I factor out 3, 5. It's a coincidence, 5, 5. You understand this exponent where I come from? Do you understand or no? Yes or no? Okay, we have you have x to the 7.
Professor.
X to the 7 in my mind, I suppose que es x to the 2nd and x to the 5. But this part go outside because it's part of the GCA, x to the 2nd. Now stay 5. This 5 is this 5. Likewise, y to the 8 is y to the cubic and y to the 5th, no? That part I factor out, look at that here, and stay to the 5th power. Plus, wait, 72, but I factor out 8. Stay only this and this. 2, 3. And 2, 3 is 9. 9. X, X, we have x to the second power. But you factor out x to the second power. So no x. And y to the 6 minus 3 is 3. Plus 9. X to the second, no? Because it's 4. If 2 plus 2 is 4. And no y. Final answer. This is factorization using great common factor. Let me see. This is the option A in the practice. Any question, guys? Of course, you need to see more, no? I have 1, 2, 3 examples of the GCF. It's clear the idea? This is important, extremely important. You need to know, you need to learn. Very important. Factorization. Factorization and GCF is the first technique you need to master. After I explain every technique, I will integrate everything in the application problem. Example 5. Example 5 is 6x12 minus 12x9 plus 18x6 minus 24 x to the third power. Again, factor out. Okay, let me try. My challenge is step 1, find the GCF. What is the GCF between 6, 12? I don't care the sign. The sign is not important. 18 and 24.
6.
It's 6. Maybe you're right. Maybe you're right. Maybe you're right. You are right. Actually, definitely, you're right. But just in case, let me check it. 6, 12, 18, 24. Quickly, I am doing the factorization. One by one number. 2, 3. 2, 6. 2, 3. 2, 9. 3, 3. 24. 2, 12. 2, 6. 2, 3. This I can see the factor is 2 is common. Look at that. Only 1. And 3 is common. Only 1. No more is common, right? Because, for example, 12 have 1 extra 2, but 6 have no more 2. Entonces es obvio. Entonces, obvio no, es important to discover que the great common factor is 6. But it's 6 in the numerical part. And what about the variable? We have x or no? No? X is common. 12, 9, 6, and 3. How many x is common? How many?
3.
3. Very well. This is a great common factor. Okay, I did the first step. Now factorization. Factor out 6x to the cube over parentheses, and it's inside. Stay. Let me see. In the original problem, it's 12, no? It's 12. Entonces 9. The entire coefficient 6 go outside. Stay only one invisible 1. And 3 plus 9 is 12. Minus 2. Look, I factor out. This guy go out. This guy go out. Only stay 2. It's 2x to the 6, no? Because 6 plus 3 is 9. Plus 3. Because this go out. This go out. Stay only this 3. 3x to the third power. Because 3 plus 3 is 6. Minus. This go out. This go out. Stay this 2. And this 2. Okay, is 4, no? X to the nothing. Oh, no, X. No X. Because we have X to the third power, and you factor out. And this is the final answer. This is one possibility. Do the factorization. The factorization is super important, in my opinion, because, number one, you can see clear what is the great common factor. Secondly, when you factorization out, you put the remaining part. Okay, another way to see is using division. 6, this 6 divided by this 6 is 1. This one is the answer here. And this 12 divided by 6 is 2. This is this. And this 18 divided by 6 again is 3. And this 24 divided by 6 again is 4. It's another possibility, no? Division. Any question? No? No question. Okay. Let's go, moving on to the example 6. It bring me new possibility, no? New thing I never see before. Example 6. Guys, this is important. Factorization is crucial in algebra. Y to the 4th power minus 47 y w6 plus 7 y cubic w8 minus 11 y4 w6. Okay. Number 1 step, GCF. Well. GCF. We have no GCF. No GCF in between 1. Look, 1 is this coefficient. 47, 7, and 11. Okay, this is the collection of the prime number. 47 is prime, 7 is prime, 11 is prime, and 1 no prime by definition, but it's obvious that we have no GCF, or actually, more precisely, is the GCF of 1. Okay? But 1 in the coefficient part. But in the variable part, we have a common variable or no? Y is common. Y. Yeah, we have Y. But Y to the what exponent? 4, 1 here, 3, and 4. It's obvious 1. And W is common factor, or no? W we have here, W we have here, W we have here, but we have no W here. Oh, W no. W is no common factor. The only common factor that we have actually is Y. And you know, when the coefficient is 1, it's invisible. My common factor, my GCF, is just Y. I factor out Y in the last step. Y to the cubic minus 47 W6, because this Y go outside, plus 7 Y second, W8 minus 11 Y third, W6. And it's the answer. Any question? Do you understand very well factorization by grouping? By grouping, no, sorry, by common, GCF. Do you understand very well? This is the first technique that we study. The first technique that we study is using GCF. Everyone, do you understand GCF?
We'll work on it.
A little bit? You need more practice?
Will work on it.
Okay.
Yeah, I need more practice on it.
I know. Therefore, that is a reason you should do the homework. I posted a new homework for that part. Guys, when you stop in any question, you email me. But I need information. Covarrubia asks me frequently because she wants to learn. But she say the problem 15, okay? I solved the problem 15 in the homework. She said que no es the same. Okay, entonces, there are no coincidences, no confusing. You take a picture, send me the picture of the question I want, I solve for you, and I solve this. No, another. Okay? Okay. Yes or no? Clear or no? Confusing?
No, I think I got it.
Got it. Okay. The second technique is factorization by grouping. Factorization by grouping. Factor by grouping. Entonces, by grouping is super easy to recognize the grouping because we necessarily have 4 terms. The expression que contain 4 terms is a good candidate to be factorization by grouping. Suppose 7, example, que es r cubic plus r squared plus 5r plus 5. Suppose que I don't know anything. Entonces, my question is GCF. Bueno, GCF here is R, pero no R here. 5, 5, no 5 here. No GCF. Bueno, actually it's 1. It's equivalent to say no. Okay? Entonces, we are doing another technique, que es the technique we studied, que es by grouping. By grouping, you pair. You pair one in either order. It doesn't matter. First, second, third, and last. And you find GCF. Now you find GCF, but by couple. What is the GCF in the first couple? What is the GCF in between R3? What is the GCF? Let me copy here. GCF between R3 and R second. What is that? What is that? What is the common factor? Tell me. R. Everyone is agree que R, 1R or 2R? Is 1R or 2R?
2 horse.
Exactly. Two. Look, let me show you. RQE is R. R second is R. The common is R squared. Okay, you take always in between. I know. Okay, R is the common factor. Common factor is R. I know. But what is the greater common factor? The greater common factor is R squared. If you factor up here, R squared. Open new parenthesis, R plus 1. So we are doing the problem like a two piece. Entonces, what is the great common factor in the second couple? Okay, 5R and 5. What is the common thing you can see? 5. Very well. Open parenthesis, R plus 1. Everyone follow me so far? So I am doing GCF, but in 2 pieces of the expression. Now, this is the most important moment. You can see that R plus 1 and R plus 1 is the same. Now you factor out one more time, R plus 1. Open, new parenthesis, and inside the new parenthesis, you put R squared plus 5. What comes from this guy? R squared is this, look. And this 5 is this. Okay? And this is the final answer. We are doing factorization by grouping. Grouping means that at the beginning we have no GCF. Okay, no. Or 1. After we are doing by couple. You separate by couple, GCF, and always happen if the exercise is good. Okay, one more time, you factorization twice, 2 times. Now you find GCF here, GCF, and you find another GCF here. And the GCF in the second step is R plus 1. You factorization R plus 1, like only one, that this, look at that. This guy and this guy go outside like only one factor. Open new parenthesis, and you put the remaining part is R squared and 5. Okay? Good grouping. You remember in high school or no? Okay, let's go to number 8 problem.
No, my usually different. That's why sometimes I don't understand.
You don't?
Yeah, when I was in high school, they were doing it differently.
Okay, bueno, okay. The mathematics is unique, only one. Of course, there are different procedures and approaches to do something. However, in my opinion, I dedicate my entire life to find the easy way to explain the mathematics. Okay?
Yeah.
I am famous. I am famous for this reason because I explain the super complicated things. So you start with me now in this intermediate algebra. If you want to navigate with me with the math in the college, I teaching college algebra after that. I teaching pre-calculus. I teaching calculus 1, calculus 2, calculus 3. This is the subject I teach in Miami-Dade College, always, any semester. Any semester, no. And this semester I teaching just this subject, pre-calculus and college algebra. But on next semester, spring, I would like, we are doing face-to-face, no remotely, it's crazy. I teach in calculus 1, calculus 3, and pre-calculus. And the summer I teach calculus. That if you, depending on your major, you like my way to explain the thing, you continue with me. Okay, you continue with me. The
Yeah,
student try.
that's
Nice, my pleasure. Okay, you say I received one email yesterday of the one student that finished with me every math. Now I am taking physics. You see, I appreciate so much the knowledge I have in mathematics that I can understand very well physics. Wow, thank you. Okay. Okay, good. Let's do in grouping. GCF, we have no. Or actually one. It's equivalent to say no. But we are doing by couple. This and this together, and this and this. Sometimes you select the couple like that and doesn't work, and you arrange in different order. But okay. Let me try now. What is the GCF in between T squared and AT? What is the GCF? Please help me.
T.
T, only one, very well. T plus A. What is the GCF in between 90 and 72? 9 is 33. 72 is 236. 18, 29, 33. Entonces, oh, es 9. Look at that. 9 que es 33. 23, actually. Es a common fact. Entonces es 9. I factor out 9. T plus A. Wow, fantastic. Look at that. When this situation happens, when you seek the same binomial, it's because almost I finish. Because in this moment, I am very, very happy. Look at my face. This is me, my picture. Okay? Because I factor out T plus A, open the last parenthesis, inside the last parenthesis we have T plus 9. Where I come from this T? This T is this T. This 9 is this. And T plus A is one package that I factor out outside. Right. The final answer is T plus A, two parentheses, T plus 9. No. Number 8. Got it? Factorization by grouping. Easy or complicated? Easy, eh?
Yeah, I'm getting it.
Yeah. Okay, that's number 9. No, number 9 now. Yeah, number 9. Number 9 is x cubic. X cubic. Okay. Plus 3x squared plus 6x plus 18. Okay. Total GCF do not exist. No. Total. In between these, and this, no. But by couple, maybe yes. The GCF in the first couple is, I need help, guys. And the GCF in the second couple is, what is the GCF between x cubic and 3x squared?
X2.
X2, very well.
X2.
I factor out x2 to stay x plus 3. Everyone follow me? What is the GCF in the second couple? Okay, yes, 6x and 8s. Say again.
Nothing.
Come on. What do you say?
Nothing.
Nothing. No, we have.
We have
6.
X.
No, X, no, we have no. We have here, we have X. 1. Here we have no X. Therefore, X is no common factor. But in between 6.
It's supposed to be 1.
No. Common factor between 6, okay, listen to me. Great common factor between 6 and 18 is obvious que es 6, no? Yes or no? Let me show you. 2, 3, 2, 9, 3, 3. Wow. Look. I can see que 2 es common and 3 is common. Therefore, the great common factor is 2 and 3. And 2 times 3 together is 6. We have x plus 3. Yes or no? Yes or no? Okay, now I can see rainbow color. Look, this factor is equal factor. How look like my face? Sad or happy? And happy or I'm sad? Happy. Entonces x plus 3. Happy. I factor out x plus 3 and stay x squared plus 6. Do you understand where I come from? This is x squared, this is x squared. And this 6 is this 6. I copy elegant way. Final answer. This is factorization by grouping. One more grouping. One more. No. We have 2, 3 more. Wow. Okay. No problem. Okay. Now number 10. Number 10 is UB is a variable minus 7U plus 5B minus 35. Okay. One clue to give me information que es factorization by grouping is because we have 4 terms. You have 1, 2, 3, and 4. Grouping, definitely. Okay, GCF in the first couple. What is GCF in the first couple? GCF in the second couple. Who help me? GCF in the first couple. U. Open parenthesis, B minus 7. What is the GCF in the second?
5.
5. D minus 7. I am happy or sad? I am happy or sad? Very happy.
Factorize it.
Yes, B minus 7, I discovered que es a common, and we have U plus 5. Final answer. Okay, what is the idea of the factorization? The idea of the factorization is completely opposite to multiplication. For example, if you want, okay, it's numerical, for example, elementary kindergarten example. Suppose 5 times 3, 15. And this direction is multiplication. And this direction is factorization. You break it down. Suppose I want to check it. This answer. I apply FOIL. Que FOIL is the technique we're always using to multiplication to binomial. So if you are using FOIL, we come back here. B times U, UB. B times 5 is 5B. Is this. Negative 7 times U is negative 7U. And negative 7 and 5 is negative 35. And we come back to the original problem. Okay? Entonces you say, bueno, professor, I understand, but I need to understand what is the application of this. You see after, I promise. But first of all, you need to learn factorization. 6R squared plus 27 RY minus 2XR minus 9XY. Okay. Again, grouping. 4. 1, 2, 3, 4. What is the GCF in the first couple?
Y and R.
R, I agree. Pero, okay, wait. Recommendation. You analyze coefficients, GCF in between numerical part, in between 6 and 27. And after you analyze the variable. I agree with you that R is a common factor, but not the greatest common factor. We need more information here. Why not? Why do not participate in the game? Because it's not common here. But in between 6 and 27, yes. I suppose it's 3. Yes or no? Let me see. Let me check in just again. In one corner of the piece of paper, I break it down to 3. This is 3, 9.
9.
Now I can see that 3, look at that, it's common factor. Then the numerical part of the GCF is 3, and the variable part is R. So we have 2R plus 9Y, no? Something like that.
Yes.
And what is the GCF in the second couple? Help me.
X.
X. Okay. He said it's X. My question is now, I agree, but it's positive X or negative X? What do you think? I factor out negative X or positive? This is always the challenge. This would be positive. Come on.
I think you will take it with the negative sign.
Yeah, you are right, mister. Okay, look at that. Suppose that I don't see that. Suppose that I don't see that. Yeah, I factor out positive X. Okay, so we have minus 2R minus 9Y. And when you compare this binomial and this binomial, wow, no equal. No equal. Sad face. Not good. No good. However, if you factorization here, minus X, everything would be different. Exactly. Okay, boom, boom. It's positive. Now, immediately, my face changed. This is me. Okay? I can see 2R plus 9Y is a common factor. And inside the last parenthesis, we have 3R minus. Done. Grouping. Factorization by grouping. It's important. Sometimes you need to analyze is positive or negative. Okay, but what's the most important idea when you are doing the factorization, if this factor and this factor is the same, we are doing well. Otherwise, no. 12. 12 is 12 minus 6y minus 2x plus yx. This sounds weird a little bit, but okay. Okay, again, let's do it in the traditional way. GCF here, GCF here. The GCF here is 6, right?
3.
It's 6, no?
You can take, yeah. You can take 3 too.
Say again?
You can take 3 too, right? 3.
No. Okay. And between 12 and 6. 12 and 6. 2, 3. 2, 6. 2, 3. It's obvious that the GCF is 2, 3, is 6. 2 minus y. Correct? Entonces, what is the GCF in the second couple? What is the common part? Can you see? Number, variable. What is the common factor? The great common factor. In the second.
X.
X. Pero positive or negative? What do you think?
Negative.
Negative X. We have 2 positive minus Y. No? Okay, let me check it just in case the sign. See, matching or doesn't match. Or doesn't match. It's minus and positive and negative. Okay, and negative is positive. Good. I am happy again because 2 minus Y is a common factor. And the second parenthesis, we have 6 minus. Final. No problem. We are the best. Okay? Any question? Any question? Factorization by group. So far, we are studying two techniques. The first one that we study is GCF. Pure GCF. Pure GCF. The second is grouping. One idea to understand the grouping is because of 4 terms. And GCF no specification. How many terms? 2 or 3 or 4 or 5 or 6. Doesn't matter. Okay, entonces the third technique we study now is the most complicated. Very, 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 very complicated. Is trinomial. Why is complicated? Because we have different trinomial. We have the regular. We have a special. And we have perfect square. But don't worry, I explain one by one. Let's working on the regular first. Perfect square. When you master regular, so we study special and we study perfect square. Okay. How do you know the regular? What is the idea for this regular? Okay, let me try example 13. In example 13, we have x squared plus 7 s plus 12. Entonces yo immediately say, wow, it's trinomial. It's trinomial. No grouping. It's trinomial technique because it's 1, 2, and 3. 3 terms. It's equivalent to say 3 terms. Good. And immediately the factorization of the trinomial, you open 2 parentheses. Always. Because it's 2 binomial. And you put a variable. In our example, it's just x. And after I need to find the number. The number is, look, I try to find 2 numbers. And that number, okay, put in the box. Your multiplication. And give me 12. And 12 is this. And this exactly the same number. You adding or subtracting, depending both or one, only one, and you get 7. Get this 7. It's obvious in this case 3 and 4, because 3 times 4 is 12, and 3 plus 4, no minus, positive is 7. You copy down. Doesn't matter the order. For 3, I don't know why. Personally, I prefer to put the bigger first. I don't know why, but it doesn't matter because the product doesn't change when you switch in the order, right? In this case, positive, no? Plus plus. Why plus plus? Because positive 3 and positive 4 is positive 12. Multiplication and addition is positive 4 and positive 3 is 7. Nice. This is the answer. Little by little, I try to explain different cases because we have several cases. This is the most elementary. Therefore, I suppose you understand very well, no? Do you understand very well or no? Trinomial identification. Trinomial 1, 2, 3. 3 terms. Number 1, I immediately identification. I open 2 parentheses because it's 2 binomial. I put a name of the variable. In that case, it's s. Now the complicated part. You try to find 2 magic number. Boom. Okay, multiplication each other. Give me 12. Okay, it's the last number, no? In the trinomial. And addition or subtraction, depending on the problem. In this case, was addition, but not always is addition. Addition or subtraction give me the middle number, que es 7 in this example. It's obvious que es 3 and 4 or 4 and 3. The order is not important. And you adjust the sign, que es plus plus in that case. Okay, let's see 14. 14 is u squared. Come on.
If the example has many solutions, that means if I don't take 3 and 4, I can take 6 and 2. That's gonna be the same thing?
No. Okay, good question. No. Why no? Suppose que you and your problem, you are doing 6 and 2. Okay, 6 and 2 is 12. I agree with you. But 6 plus 2 is 8. And 6 minus 2 is 4. Never 7. Therefore, that combination doesn't work. Clear?
Yeah.
Okay.
Yeah. Thank you.
Yeah, it's important. Because this is easy, but another more complicated example. Oy, you need to try an error. Yeah, it's try an error. Okay. Okay, let me try. Okay, let's go to the number 14. No? 14 is U square. 14. It's a coincidence to get 14 example and 14 number. Okay, okay, okay. Is trinomial yes or no? Is trinomial yes or no? Yes or no?
Yeah.
Yes. And also is regular. I forgot to explain what is regular. Regular is when the coefficient in the front, the quadratic term is 1. Here. This is invisible one. When the coefficient is no 1, suppose another problem, que the coefficient is 2, 3, 4, 5, is special. And the special we are doing a little bit different. A little bit different. Entonces immediately I recognize trinomial yes, regular yes, super easy, open two parentheses. You put the name of the verb, que es you, and you try to find the combination. Two numbers can multiply each other, give me 14. And when you adding or subtracting, give me 9. What is the answer? What is the combination, in your opinion?
7 and 2.
7 and 2. Very, very well. Because 7 times 2 is 14. And 7 plus 2, so 7 times 2 is 14. And 7 plus 2 is 9. This combination is good. And this, now, look, the sign is negative. Why is negative? Because this sign is negative. When this sign is positive, in the 13 example was positive both. In this case, it's negative both. I want to explain in detail after. Okay, in this case, it's no coincidence. I create intentionally that this sign is positive. And this sign is positive in both examples. Si es negative, entonces something different happens. Pero si es positive, it's nice. Because when it's positive, it's the same sign. Depending the sign of the first sign. Si es positive, positive both. Si es negative, negative both. Okay? And this is the answer. This is the final answer. Wow. It's the final answer. Okay. Let me try 15. 15. Guys, we are doing trinomial. Trinomial is very, very complicated. X to the second power minus x minus 6. Okay? Trinomial, yes or no?
Yes.
Yes. Regular, yes or no? Yes or no?
I think it's just regular.
It's regular, yeah. Why? Because coefficient here is 1. Look, when the coefficient is 1,
Yeah.
it's regular. It's regular. Okay, entonces I open immediately two parentheses. X. Now I try to find two numbers. They multiply each other, give me 6. And when you're adding subtraction, give me 1. Okay, 6 and 1. 6 is this 6, and 1 is invisible. Actually, it's negative 1. No? I try to find two numbers can multiply. When you multiply this number, I try to find, give me 6. I don't care the sign. For the moment, I don't care. For the moment. And somehow, when you're adding or subtracting this magic number, give me negative 1, or doesn't matter, 1, just 1. You get the answer or no? What is the number? What is the number? What is the number? What is the number? 3 and 2, 3 and 2, 3 and 2. The number is 3 and 2. 3 times 2 is 6. And 3 minus 2 is 1. I don't care the sign. The sign is not important now. So you copy 3 and 2. Guy, I prefer put the bigger first. I don't know why. Doesn't matter, but okay. Now you adjust signs. This is a crucial moment. Adjust the sign. And this sign is negative and positive. How do you know that? Well, because negative 3 times positive 2 is negative 6, like this. And negative 3 plus positive 2 is negative 1, like this. Okay. This is understandable. However, I want to create a shortcut to do this in 1 second. 1 second. Okay. Okay, you analyze the sign. Look at that. Let me analyze these 3 examples we are doing of the trinomial. Let me make a zoom. Yeah. In the first example, okay, any trinomial, guys, pay attention. This is important moment. Important. Pay attention. Using rainbow pen. Okay. In the first example, it's okay. In the first example, okay, in the trinomial we have 2 signs. This sign and this sign. I want to call first. I want to call second. It doesn't matter. So when the second sign is positive, like this example and this example, we have always the same sign, plus or minus, depending the sign first. Okay. When in the 15 problem was this is the second sign, this is the first one. When the second sign is negative, we expect different sign. When the second sign is positive, it's the same. Okay, let me go over here. Second sign is positive, automatically, same sign. Second sign. Is negative, different sign. Okay, and that's it, no? No, because so what sign I define, I adjust the sign, Well, okay, you adjust. See, it's the same, is the sign of the bigger number. Let me erase that part. Let me try to erase it. What sign I adjust? Bueno, is the sign of bigger number is equal the first sign. Okay. So in this case, look, what's the bigger between 3 and 2? Is 3. And the first sign is negative. So you assign directly. It's negative here. And the other is different. Okay? Okay? And the other is different. One is different sign. Okay, different, okay. Different. But I know that the bigger number have the same first sign and the other is different. Okay, maybe look like confusing. However, I propose to do more examples. I propose to do, for example, example number 16, no? 16. 16 is good. 16. 16 is x squared plus 4 x minus 21. Okay, Apple is trinomial, of course. Is regular, of course. Therefore, the factorization is 2 parentheses. X. And the number is, what is the number? 2 numbers que multiply give me 21. And when you addition or subtraction, give me 7 and 3.
3. Yeah.
Okay. The problem of the sign is the complicated part. You see this sign is negative. We expect different sign. See, this sign is positive. You expect the same. But no. Our example is negative. So it's different sign. And this sign is the sign of the bigger number que plus. And the other is different. You see this, let me explain one more time. See, this sign is negative. We expect different sign. One positive, one negative. But this is the sign always of the bigger number. Yes, sir. Don't. More clear now?
Yes.
Eso. Okay, the I is important, extremely important because we have to do factorization, a lot of factorization. 17. 17 is x squared minus 2x minus 80. Okay, trinomial again. Regular trinomial because the coefficient here is 1. Open two parentheses, put the name of the variable, que is x in that case. And I try to find the combination. The combination of two numbers can multiply each other, give me 80. And when you subtracting or addition, I don't know, give me 2.
5.
5 and?
5 and 2. 2. No.
No. 5 and 2 is 10.
No. 5 and 6.
5 and 6.
No. He's not gonna be
8 and 10.
8 and 10. Very well. 10 and 8. Okay. Listen to me. Let me try to explain what to say. You guessing, you look into the ceiling, and you ask for the God, give me the number matching in this example. No. 80. You copy one corner of the piece of paper. 80. 80 is equal 80 times 1. And you adding 81. And you subtracting 79. And this doesn't match it. This and this no. With the number here, get 2. Again, 80 is equal 40 times 2. 42 and 38. No. And you continue. Boom. And you get, for example, 80 is equal 10 times 8. Is when you adding it's 18. When you subtracting it's 2. I got it. Is this combination. Okay? This is the systematic way. And of course, you use a calculator. You put in a calculator. Divided by 2, 40. Divided by 3, no. Divided by 4, yes, it's 10 and 4. And so you try one by one. And I know it's too long process, but you get the answer. It's better to guess it. What about the sign? What do you think about the sign? Same sign or different sign? Same or different? Same sign or different signs? Different. Who is positive? Who is negative?
X.
10 is positive.
10 is positive. 10 is negative. And 8 is positive. Remember, when this sign, I repeat again, this idea gets hard to memorize. When this sign is negative, we expect different. Yes. But the difference is this sign, let me use another color to highlight this sign. This sign is the sign that you assign to the bigger number, and the bigger is 10. 10 is bigger, and the other is different. Super? No problema? Do you understand regular trinomial? This was 17, no? 17. Now 18 is the last one. 18. No, not the last one. No, the last one of the regular elementary. 18 is r squared plus 2r plus 24. Regular trinomial, nice. I open two parentheses. I put a variable que es r. They try to find the combination, que es the complicated part. Two numbers can multiply each other, give me 24. And somehow when you're adding or subtracting, give me 2.
6 and 4.
What's the again?
6 and 4.
6 and 4. 6 and 4 is okay. But what about the signs? Same sign or different sign?
Same.
Same sign. What sign? Positive. Entonces, I put this example because it's weird. Very, very weird. Suppose que es plus, plus. Okay. Entonces, I want to illustrate que not always is possible factorization. And also, I want to illustrate que it's important that you checking each factorization that we are doing. So what is the idea for checking? Well, you FOIL. You multiply r times r squared. For r, 6r, and 24. And when you combine that term, r squared plus 10r plus 24. No, it's not the same for the origin. This factorization is completely wrong. Well, professor, okay. I do something to fix that. I change the sign. Suppose 6 and 4 very well matching because I know that 6 times 4 is 24 and 6 minus 4 is 2. So something is 1 is negative, no? At least 1 is negative. What do you suppose is negative? What do you suppose is negative? 6 or 4? Suppose que es 6. And you apply FOIL again. Look at that, what happened. R squared plus 4r minus 6r minus 24. When you combine that term, we have 2 mistakes. Well, minus 2r minus 24. Wow, it's not the same. It's negative 24, no positive 24, and it's a negative 2, and it's completely different. And so you suppose in other order you get the wrong answer. Therefore, guys, this trinomial is impossible to factorization, and when this situation happens, it's called a prime. It's prime, like the prime number. For example, you can break it down 5? No. 5 is impossible to break it down. 7 is possible to break it down. No. 1 is possible, 1 and 5 is the only possibility. This is prime trinomial, therefore it's impossible factorization. This situation, no, it's not common to happen, but it happens. Okay, any question?
No.
No. Okay. I am boring, you are boring, or you are strong? Okay, we continue trinomial.
No.
But this is similar now, very, very similar, except that we have 2 variables. And this change a little bit, but not too much, the problem. Look. Okay. Okay, the trinomial 1, 2, 3 is regular because we have 1 here. Nice. I know the professor said that immediately, don't waste the time, you open 2 parentheses. You put the name of the first variable is x. The first variable is x. I don't care the y for the moment. I try to find the combination. 2 numbers can multiply each other, give me 35. And 2 numbers can multiply, give me 35. And when you're adding or subtracting, give me plus or minus, give me 2. You get the number or not yet? Help me.
5
2
and
numbers,
5 and 7.
5 and 7. Very, very well. Very is 5 and 7. 5 times 7 is 35. And 7 minus, in this case, using the sign, minus 5 is 2. Super. Now, the new thing is that you copy 5 and 7, but using the name of the second variable. It's 7y and 5y. Okay? It's the new thing. When you have trinomial that contain 2 variables, x and y, or u and b, or either one. What about the sign? We expect same sign or we expect different sign? Who is positive, who is negative, or both negative, or both positive? We have 4 combinations.
One has to be positive.
Wait. Okay. Question number 1. Question number 1 to solve it. Is the same or is different?
Different.
Exactly.
Different.
Different. Why? Because it's negative. The second sign is negative. Different. Who is positive? Who is negative?
The second one might be positive. I mean,
Exactly.
yeah,
Positive 7 and negative 5. Because this information, this give me information gets different. And this is when immediately this sign just copy and paste here and the bigger number. And the other is different. No? Just in case I want to make sure everything is okay, foil, quickly foil, quick foil. X times x, x squared. This and this is minus 5, xy in alphabetical order. This and this together is 7, xy. This and this is minus 35, y squared. When you combine like term, 7 minus 5 is 2, like this. Okay, this is verification. Not always is necessary to do that, but I recommend, strong recommend verification if your factorization is fantastic, it's perfect. Okay? 20. 20 is similar. Is regular trinomial, but contain two variables. Okay. Is u squared minus 3ub minus 28b squared. I try to find the factorization. Okay, I know it's regular. You open two parentheses. I put the name of the first variable u. Nice. Now the complicated part, a combination. Two numbers can multiply, give me 28. And somehow when you adding or subtracting, give me 3.
7 and 4.
Exactly. 7 and 4, she said. 7b, don't forget the name of the second variable and 4b. Because 7 times 4 is 28, and somehow 7 minus 43. What sign? What sign? Who is positive? Who is negative? It's negative both, or it's positive both? What do you think?
7 is negative and 4 is positive.
7 is negative, she said. I'm positive. Any question? Remember, one more time, I repeat. This sign indicate me is different because it's negative. And this sign indicate me the sign of the bigger, and the other is different. Just in case, if you want to verification, you apply for it, and we come back at the beginning. 21. 21. 21. 21 is u squared minus 4ub minus 45b squared. Wow, again, trinomial. What kind? Regular. Open two parentheses. You put the name of the first variable, get u. Now I try to find the combination. Two numbers can multiply, give me 45, and when you add it on subtracting, give me 4. I don't care the sign. The sign is not important. In the analysis, is not important now, the sign. Some students confuse 9 and 5, 9 and 5, 9 and 5. 9 and 5, we are right, 9 and 5. So say 5. Remember, I like so much to write the bigger first. Es nice, sorry, carajo. Okay, 9, B, and 5B. Okay, 9 times 545, 9 minus 5 is 4. Okay, this is good. What sign? Different or same?
Different.
Different. What is positive, what is negative?
Different.
9 is negative.
Yes.
Very, very well. 9 is negative. 5 positive. Wow, we are the best. We are the best. Everyone follow me, guys, because maybe some people are shy and don't want to share your question. No? That's what this 21, 22, 22, 22, 22. 22 is a little bit more complicated because 22 have a big number. X squared plus xy minus 128. Wow, y squared, 128. Hey. I suppose I need to use my calculator. 128, 128, 128. Let's okay, you open the parentheses again. You put the name of the verb, first verb is x. Now the combination is complicated. At least for me, it's complicated. I don't know. 128 is even number. You can divide it by 2. You can divide it by 3. By 3, no. By 4, yes. By 5, no. Okay. By 7, no. By 8, maybe, no. Okay, let me try. This is try and error. Try and error. Try and error. Suppose divided by 2 is 64. I put in my calculator. But when you add in this, this is 66 and 62. Never we get 8. I suppose we keep going. Tac, 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 tac. Suppose I divided by 8. It's possible divided by 8. 100, let me see. 128 divided by 8 is 16. 8 and 16. When you adding a 24, but when you're subtracting 16 minus 8 is 8. And this is the combination. This is the combination. And the combination is 8 and 16. They copy 16y. Don't forget the second variable. And 8y. What about the sign? Who help with the sign? Different, the same. Who's positive, who's negative, both positive, both negative. Go ahead. Go ahead. Activate the microphone, the people who want to try.
16 is positive and 8 is negative.
Best. You're the best, miss. Exactly. It's the answer. Wow. We are the best. Okay, that's so far, guys. We studied 1, 2, 3 technique of the factorization. The first one was GCF. The second was grouping. Grouping is 4 terms. And trinomial is 3 terms. And inside the trinomial,
How you know when to stop
go ahead. Say again.
how you know when to stop factoring between 16 and 18? I think
Well,
4 goes.
no. I don't know. I try to investigate here. Suppose, I keep going. I put dot in order to save time. But in the real life, you continue. You divide it by 4. I put in my calculator 128 divided by 4 is 32. It says 4 and 32. When you adding, it's 36. When you subtracting, it's 28. Remember, my goal is 8. So I know it doesn't work. We continue. By 5, it's impossible. When you put in a calculator and you divide by 5, it's decimal. No, doesn't work. You divide by 6, maybe, I don't know. It's decimal. Doesn't work. By 7, decimal. Doesn't work. By 8, by 8 is 16. When you divide by 8, it's 16. And 16 and 8, when you adding is 24. When you subtracting is 8. Exactly the same number that we need here. Is 8. We need. Do you understand, mister?
Yes, Professor. Thank you.
Pleasure. Now, I try to explain that so far we studied 3 techniques of the factorization. Okay, you cannot forget the next time. Okay, the last one was trinomial, que es easy, pero regular. Trinomial. Let me try in the 5 minutes that I have to introduce special. Special is special. Special, in my opinion, is the most complicated case in factorization problem. We have 23. 23 is 12 x to the second plus 17 x plus 6. Okay. Because I want to explain two different ways to, this is special, this is trinomial. How do you know it's trinomial? Because we have 1, 2, 3. And this is a special trinomial. Why is it special? Because the coefficient here is not 1, it's 12. Well, it's special. Immediately I open two parentheses, but in this case, no. So there are two different ways to solve the problem. One is called, so the first approach is by grouping. It's called by grouping. But you say, well, professor, but by grouping you apply when you have 4 terms. Okay. In this case, we have 3. And another is try and error. Try and error. Try and error. What's best? Depending on the problem. Sometimes it's best try and error. Sometimes it's best grouping. Depending the numbers. Depending the example. Suppose 12 x squared plus 17 x plus 6. Immediately you multiply this number and this number. Whenever I'm doing that, yeah, I don't do that because I suppose in the regular trinomial, this coefficient is 1. So the multiplication is always 6, but in this case, no, it's 72, no? It's 72. Well, 16, I put it in my calculator, 16 times, 12, sorry. 12 times 6 is 72. So I try to investigate the factor of 72 to somehow give me 17. In this case, I suppose is 9. 8 and 9, 8 times 9. It's okay. 8 times 9 is 72. Somehow 8 plus 9 is 17, right? Okay. And this number is not the final answer. No. This number helped me to break it down this in 4 terms. So far we have 3 terms. And now I copy the first exactly the same. I don't touch the first, I don't touch the last. I split 17 using this combination. Doesn't matter what order. Plus 9x, doesn't matter. The order is not important. Okay, and you convert this now in 4 terms. Into the 4 term, it's ready to apply factorization by grouping now. Let me try, make it soon. Grouping now. Grouping. GCF here and GCF here. What is the GCF in the first couple? Well, I suppose que es 3, no? 3x. Yeah, because 12 is 2, 6, 2, 3, 9 is 3, 3. It's all because 3 is a common factor. Okay, 3x. So we have 4x plus 3. And the GCF in the second is 2. It's 2. And between 8 and 6. 2, 4, 2, 2, 2, 3. It's all because 2. That's 2, just 2. 4x plus 3. Wow. So this is typical grouping in which I am so happy because we get exactly the same and you factor out 4x plus 3. And the last parenthesis we have 3x. And this is the final answer. Complicated? Very complicated, eh? Especially very, very complicated. And last time, I want to explain try and error. Okay, try and error, maybe you like. Personally, I don't, but some problem I consider it is good doing by try and error. But grouping is fantastic. I like so much grouping. But okay, what is the disadvantage of the grouping? When you multiply this number and this number, in this case, 72, but in other case, in other example, it's 2 200 or 100, o sea, a number bigger than 100, entonces it's too complicated doing it that way to find the combination. However, try and error is easier. This is the only advantage or disadvantage. Because remember, guys, let me see your face now. Stop sharing. Okay, remember, today, the most of the students send me the test number 2. Good, very good. Remember, tomorrow in the morning, I grade test number 2. Any problem with the code online, please email me. No. Christian, no. You email me. And you explain me your problem. We try to find solution. Temporary solution, because definitely for the test number 3, everyone need to have the code and everything, the machine working perfectly. Okay? Any question?
Professor,
Please.
I sent you an email.
Okay.
Yeah,
Okay,
about
Christian.
the exercise. Me,
Okay,
no
Christian.
Fender.
Christian, the student is talking now?
No, Ernst.
Ernst. Okay.
Right.
Any other question? No question. Okay. Bye. Have a nice day.
Bye.
Thank you. See you.
You too.
Okay.
Thank you, sir.
Pleasure, always.